Friction is a force that comes from the locking together or scraping of two surfaces. It always opposes an object's motion.
There are two main types of friction: static friction and kinetic friction.
Static friction acts on objects that are at rest. Static friction is why I can't push this water cooler. No, so heavy.
In this scenario, the normal force on the water cooler, multiplied by the static coefficient of friction between the cooler and the floor, is greater than the force of David pushing. The force of friction will oppose David's force with a force of the same value, causing the cooler to stay in equilibrium and not move. Kinetic or sliding friction acts on objects that are in motion. Kinetic friction stops this bottle from sliding all the way into the kitchen.
The force of friction acts in a direction opposite of the bottle's motion. This gives the bottle an acceleration opposite to the bottle's velocity, causing it to slow to a stop. The force of friction is less than or equal to the coefficient of friction times the normal force, or mu times n.
The normal force is equal to the mass of the object times the local acceleration due to gravity. On Earth, the local acceleration due to gravity is 9.8 meters per second squared. On other planets, this acceleration would be different, meaning that the normal force would change, and the force of friction would also be different on these planets.
The coefficient of friction is a value that differs depending on the two surfaces rubbing together. For any two surfaces, there is a static coefficient of friction and a kinetic coefficient of friction. The static coefficient of friction is higher, which means it is harder to get an object moving than it is to keep it in motion while it is already sliding.
The friction between two surfaces converts kinetic energy into heat. This is why rubbing two sticks together can create a fire. Because friction causes objects to lose velocity, the kinetic energy has to go somewhere. Because energy cannot be created or destroyed, it has to be conserved. With friction, the kinetic energy is most often converted to heat or sound.
We designed an experiment to find the static coefficient of friction between a wooden train's wheels and various surfaces. You may be wondering why it's the static coefficient of friction instead of kinetic, because the train is moving. Actually, because the wheel is rolling, no one part is actually sliding, so the static coefficient of friction is used. We used math in addition to our knowledge of forces and kinematics to derive an equation for static coefficient of friction based on how far the train rolls. Now we just need to collect our data.
Go for it.